Today we are going to discuss the shock waves. Already we have gone through the oscillations, and the second part is nothing but the waves. That is the shock waves we are going to consider. Now, what exactly these shock waves are? Prior to that one, we will try to discuss something, the basics about the wave. What is wave? This is in general what the definitions I am adding here. So it's a sort of the disturbance in a medium. The wave may be of any nature. It is a sort of a disturbance in a medium. Next, what the sound waves are. So it is the pattern of disturbance caused by the energy traveling away from the source. This is one, and another thing it may be given as sound is a form of energy which makes us hear. So whenever there is an impact of the sound waves on the ear, so we hear that one. Those sound waves are recognized by our ears. Next, what is fluid? So fluid, it is a substance that flows when subjected to shear force or external force. Under the external force, that fluid is the one which flows. In general, we call it as the fluid. Next, the fluids are classified as the liquid and into gas. What the liquids? So liquid, there is a negligible change in volume for large change in pressure. So whenever there is a large pressure, for that large pressure, there is a negligible change in volume takes place. So such the things are called as liquids, and these are even known as incompressible fluids. So liquids are incompressible fluids. Next, gases. What are gases? So these, what happens in gas? So there is a large change in volume for small change in pressure, opposite to this one. Means even for small change in pressure, so we observe large change in volume. So these are known as gases, and these are known as compressible fluids. So liquids are incompressible while the gases are compressible fluids. Next, acoustic waves. What are the acoustic waves? So these are the longitudinal waves that travel in a medium with the speed of sound in that medium. So these are the longitudinal waves, so which are traveling in a medium. So and other thing is that their speed is equal to the speed of sound in that particular medium. And we know that the speed of the sound in air is 333 meter per second. So these are acoustic waves. Now such acoustic waves are classified on the basis of frequency. Based on frequency, the acoustic waves are classified as infrasonic waves. What are infrasonic waves? Based on frequency, the waves whose frequency is less than 20 Hz. Those are known as infrasonic. Then audible, the human ear, what we are quite sensible, its frequency is 20 Hz to 20 kilohertz. So we people are quite sensitive for this 20 Hz to 20 kilohertz. It is known as audible wave. Then ultrasonic waves. So ultrasonic waves are the waves whose frequency is greater than 20 kilohertz. Those are known as the ultrasonic waves. Next, based on the speed of the fluid or the object, so they are classified into two things. One is subsonic and second is supersonic. What is subsonic? The object speed less than the speed of the sound is known as, whenever the object, whatever the object it is moving, if its speed is less than the speed of sound, it is known as subsonic speed. And fluid velocity associated, whatever the fluid, suppose it is a fluid velocity is associated with that one, it is known as subsonic flow. It means the speed, it is less than the speed of the sound. Second is supersonic, where the object speed greater than speed of sound in the speed than it is greater than the speed of the sound. If whatever the object is moving, if its speed is greater than the sound, okay, speed of sound, it is known as supersonic, and the fluid associated is known as supersonic flow. One is subsonic and supersonic based on speed of the sound. If it is less than speed of sound, it is subsonic, and if it is greater than speed of sound, it is known as supersonic. See, what all we have discussed, these are the basics which is essential. So based on this one, see, sometimes we have used the frequency here, and here the speed we have used. Okay, so it is each time it is very difficult to specify whether we are talking in terms of the frequency or the velocity. Therefore, there is a method. Okay, so based on that one, the objects, they are classified. Here we are going to introduce a more detailed classification is based on a new parameter known as the Mach number. What is this Mach number? So this Mach number may be defined as, it is the object speed divided by speed of sound in the medium. So this ratio we call it as Mach number. That is, it is defined as the ratio of the speed of the object to the speed of sound in the given medium. So this is known as Mach number. So this Mach number, it plays a very important role in this particular chapter. So let me repeat once again, the Mach number is defined as the speed of the object divided by the speed of the sound in that medium. So maybe it may be given by notation V by A, where V is speed of the object, A is speed of the sound in that particular medium. So this is, so later on we are explaining only on the basis of this Mach number. And as we have discussed, the speed of the sound in air is 333 meter per second at standard temperature and pressure. Now, yes, based on this Mach number, the classification is as follows. Okay. First one, the incompressible flow. What is incompressible flow? If the Mach number is less than 0.3, if the Mach number is less than 0.3, we call them as the incompressible flow. Second one is subsonic flow. In the subsonic flow, where the Mach number lies between 0.3 and 0.8, that is, it lies between 0.3 and 0.8, it is known as subsonic flow. And the third one is transonic flow. So where the Mach number lies between 0.8 and 1.2. So such flow is known as transonic. And what is supersonic? Where the Mach number is between 1.2 to 5. It lies between 1.2 and 5 is known as supersonic flow. And the last one is hypersonic, where the Mach number is greater than 5. So whenever it is greater than 5, we call it as hypersonic flow. So this may be given in the form of the chart. This is the Mach number. It starts from 0 to, Mach number increases up to 0.3 incompressible, 0.3 to 0.8 it is subsonic, 0.8 to 1.2 transonic, 1.2 to 5 supersonic, 5 and above it is hypersonic flow. Now we observe this, the transonic flow. It is between 0.8 to 1.2. Because it was very difficult to distinguish this subsonic and supersonic flow, as we discussed previously, subsonic flow and supersonic flow, it was very difficult to distinguish. It overlaps. So if you take 1.0, it was very difficult to find, distinguish between based on this 1.0. Therefore, so there was a region, the flow, so which is the combination of both the subsonic flow and the supersonic flow. Therefore, that region was taken as between 0.8 to 1.2. This region is known as transonic flow. Now, a few examples just we'll observe here. What is the subsonic flow? So, in the subsonic flow, Mach number is between 0.3 to 0.8. Suppose you imagine this is the plane, the aeroplane which is moving, and such that the velocity is less than the speed of the sound. V is less than a. Means the object which is the aeroplane which is moving, its velocity is less than the speed of the sound. Okay. Whenever such thing it is moving in the medium, at that time, for a body moving with subsonic flow, the sound emitted by it manages to move ahead and away from the body. Try to understand here. Whatever the impact is produced by the object, it moves ahead. So you can, in front of this object, its effect we can observe here. Even backside it is there, but even it is ahead of that particular the object which is moving. So such type of the disturbance will be observed in subsonic flow. So almost all the automobiles which are in our day-to-day life, we come across a car, the motorbike, the train, the super speed train, whatever the means major the automobiles which are moving, they fall in this category. Those are known as subsonic flow. Here V is less than A, and whenever the object is moving, its disturbance is quite ahead of the object. So such thing is known as the supersonic flow. Next one is supersonic flow. So in the supersonic flow, the object is moving. You can take it as a rocket. At that time, you usually can take the fighter plane, in the military. So their velocity is greater than the velocity of the speed of the sound. V is greater than A. At that time, what happens? Whatever the disturbance caused by that particular object, it is left behind, and the object is quite ahead. You can observe here, object is quite ahead and its disturbance, they are left behind. So such thing we are going to know, it is known as supersonic flow. And usually the fighter planes nowadays, they are capable to have the supersonic flow. Now we are going to discuss something about the Mach angle. See, Mach angle, how we are going to define mu as it is defined here in this diagram. The angle made by the tangent with the axis of the cone, the half angle cone is called as. So this is the axis, and whatever the tangent which is common drawn to this, the disturbance, the angle, the angle made by the tangent with the axis. So this particular angle we are going to known as Mach angle, which is denoted as mu. Therefore, mu is given by mathematically sine inverse of 1 by m. So Mach angle, mu, this particular the mu is given mathematically as mu is equal to sine inverse of 1 by m. Next, what are the shock waves? So already we have discussed what wave is and different types of the category, what are the different categories they come across. Everything in introduction we have discussed. Now what the shock waves are. See, any wave that propagates at supersonic speed gives rise to a shock wave. It means for the shock waves we observe that V is greater than A. So whenever V is greater than A, it leads to the shock waves. They are produced by a sudden dissipation of mechanical energy in medium enclosed in a small space. So shock waves are produced in a very small region, very thin region, in a very thin region the shock waves are produced such that there is a dissipation of mechanical energy and the region is compressed. See here, the region is compressed in such a way that this small region, in this small region, the air or whatever the air, suppose if it is the air media, so this particular air media, what we observe, the volume decreases suddenly due to this mechanical energy, the volume decreases and pressure increases. Due to this, temperature in that particular region, it increases tremendously. So this is known as the shock waves. So let me repeat once again. So there is a compression of the liquid, sorry, or we can take the, for time being, the air. So suddenly suppose in between these two, the air we are considering. Suppose there is a compression, all of a sudden the region between these 2 points, it compresses. Then what happens? Here the volume decreases, pressure increases, and we observe the temperature rises. Okay, so density increases obviously. So these are the physical things which we observe in the shock waves. So how we are going to observe the shock, define the shock waves? A shock wave is a narrow surface, it is a very thin surface that manifests as a discontinuity of fluid in medium in which it is propagating with supersonic flow. So this is characterized by what happens in that particular region, characterized by sudden increase in pressure. Pressure increases, temperature and density also increases. Pressure, temperature and density increases while the volume decreases of the gas through which it is propagates. Okay, in simple words, it is a mechanical wave. Whenever it propagates in a media, the volume decreases, pressure, temperature and density increases. So this leads to the shock wave. Even you can define in the simple words also. So with example you will come to know. And whatever the thickness I said, the volume decreases. The region across which the volume decreases, it is of very thin region, that is of few micrometers. So this shock waves are produced within a small area, the region. Its thickness is of around few micrometers. Very thin region, shock waves are produced, but impact is very high. So classification of shock waves are weak and strong. The first one is weak shock wave. What are weak shock waves? Here the explosion of the cracker. So whenever the crackers explodes or the tire burst, whatever the sudden the impact we observe, the sound, of course we realize with sound, but in that small region what happens? The shock waves are produced in such a way that the volume decreases, temperature, density and pressure increases. So these are known as the weak shock waves. Then the strong shock waves. Suppose the lightning thunder uses, okay, thundering effect, or the lightning of the the thunder effect, it is also leads to a shock waves. Then use of the bomb, whenever the bomb are used, okay, the effect whatever is caused, it leads to a strong shock waves. And nuclear explosion is taken to be the strongest one of these all the shock waves. Whatever the nuclear explosion takes place, at that time the area around that one, you might have observed in some videos the explosion of the nuclear explosion, okay, some circular the waveforms are produced. So those are the shock waves known to be the strongest shock waves. And even the earthquakes are considered to be the shock waves, strong shock waves. So these are nothing but the different types of the shock waves. Next one. Then what are the properties of the shock waves? The properties of the shock waves are they always travel in a medium with a Mach number greater than 1. So whenever the shock waves are produced, its Mach number is quite greater than 1. They obey laws of fluid dynamics. So usually fluids, that's why I have taken in the introduction what fluids are. So whatever the laws they are applicable for the fluid dynamics, same they are applicable here also. Next, the effect caused by shock wave results in increase of entropy. So due to the shock waves, whatever the disturbance is observed in that media, it is that results in increase of entropy. In short, we can call it as entropy in the sense we can take into account as measure of disorderness. So there is lot of disorderness in the surrounding region whenever there is a impact of these shock waves. Next, across the shock waves, supersonic flow is declarated into its subsonic flow. This process occurs adiabatically but with a change in internal energy. So whenever the shock waves are produced, they will be initially in the supersonic flow and slowly they are declarated into a subsonic flow. Means they will, from supersonic they will move into subsonic flow, such that process is adiabatic in nature. It means this process occurs without exchange of heat. So there is no exchange of heat that takes place in this process. It is adiabatic process. The next one is the thickness of the shock waves present in the medium. They are of few micrometer, usually less than 1 micrometer. So whatever the thin region in which the shock waves are produced, so that region is less than 1 micrometer, around 1 micrometer range. In a thin region, the shock waves are produced. Next one is they are not actually wave like in convention sense. It is usually expressed as shock front. So sound waves are there. So like sound waves, the shock waves are not that type of the waves or the ordinary waves, speaking conventionally, but therefore it is expressed in terms of shock front. Shock front means a small region which is enclosed, the shock waves. Okay, I mean it is being enclosed by a small region. So that the whole thing we are going to call it as the shock front. Next one is on impact, they physically travel through any media. Whenever the shock waves they come and hit any media, surrounding media, then the shock waves are traveling through that particular media. It means they are capable enough to travel in any media whichever it comes in contact. So these are something about the shock waves.